Hi everyone, welcome to Linear Model with me, Sarini Abdullah. In this video, we will learn about logistic regression. So, before we learned about multiple linear model, that is, we have a target variable explained by several predictors denoted by x1, x2, x3, all the way up to the xp in here. So this is our target, usually symbolized by y. But now, what if our target is, instead of having a ratio or numerical measurement, it is just in a categorical variable, especially in this case is binary target variable that takes the value 1 if there is a success and 0 otherwise. I mean that we can say it as success and failure, or 1 if category A and 0 if category B, or something like that. The main point is that y only takes two categories of variables. And then, so in here, instead of having 0 and 1, we can see like, the likelihood or the probability of each of the observation, whether they will go into success category or into not success category. And then the higher the probability of getting into category success, then later on we will just classify this observation into the category of success and the other way around. So it can be represented by the logistic function in here. Now, how about the model? So we have that, our multiple linear model takes the form of expected y equals beta naught plus beta 1 x1 plus blah 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 up to plus beta p xp. So actually similar thing we will apply in here for our binary response. But then we just need to consider that on the right side of the equation in here in the model, since we cannot control the value of beta naught, beta 1, or to the beta p, because they are just resulting from, the estimation given the data on x1 and so on. So we just take that there is no limit to the value of the right side of the equation. That is, they can take value from between minus infinity to infinity. While on the left-hand side of the equation, we know that our y is of binary measurement that takes only the value of 0 and 1. So in this case, we need to do something for the form of expected value of y. We cannot just take expected y where y is 1 or 0, because they are not equivalent. On the right side is just 0 and 1, on the left side is just 0 and 1, while on the right side is from minus infinity to plus infinity. They are just not comparable. So we have to do something about this. And what is that something? Now let's just try to do some kind of transformation to make that both sides of the equation are parallel or equivalent. So then the first step to do is that, okay, let's just change this categorical value. That's the one that we have in here, the category here, 1 and 0. Change it into a little bit numerical value. And then we can do that by having, instead of just 0 and 1, we can just take the expected value of y as the probability of getting into one of the category. In this case, we just take probability of y equals 1. So there's a hope that if we have this as the term for the left-hand side of this equation, at least now they are both in a numerical scale of the measurement. But then we just check it again. Probability, the value is limited, is confined just between 0 and 1. while again what we have here is should be from minus infinity to plus infinity. So it means that we cannot just stop here, we have to do something. Further, let's try, okay, how to transform or how to get, that wider range of values from 0 and 1. And then we can think of what about if we do the proportion of pi here relative to 1 minus pi. So in this case, we can see that we can extend the coverage of the value. That is, if pi close to 0, if pi close to 0, then we can have that this whole thing will close to 0, right? Because here almost 0 divided by here 1 minus something close to 0. So almost 0 divided by something almost 1, so it should be close to 0. On the other hand, if we have pi close to 1, then we will have, okay, this one is close to 1, but on the denominator, the value is close to 0, so the ratio here will close to infinity. Okay, that's better. So we have that the range of pi on 1 minus pi is from 0 to infinity. That's good enough. That's better than just having pi as our response variable. But it is still not equivalent with the one that we have in here on top here. What we need is not 0 to infinity. What we need is from minus infinity to infinity. It means that we need to do something more. And then in here, let's think of how to extend the value from 0 to infinity becomes minus infinity to infinity. And if we recall our mathematical background in logarithm function, then we can apply the natural logarithm function in here. Because we know that, okay, for the value close to infinity, then the logarithm of that value will also be close to infinity. But for the value less than 1, then that less than, for example, this is not 1 because we are using natural logarithm. For value less than 1, then the value of the logarithm will be negative. And the closer the value to 0, then the value of the logarithm will be close to minus infinity. So that's, we get it. So if we have logarithm of pi over 1 minus pi, then we will have the range of the values is between minus infinity to infinity. So then we will have our model, instead of having expected y, then we have the response variable is logarithm of pi over 1 minus pi would be a better choice to model this problem. And then this is called the logic model. So logarithm of pi over 1 minus pi is called the logic link function, where the pi over 1 minus pi is called the odds, or sometimes we call it as the risk.